Hello, my name is Alex. In this series of video tutorials, I'm going to show you how to add functionality to your Magento installation. You can search the web and find any number of pages showing you how to create a Hello World module in Magento, for example. The problem is, when you dig deeper, you'll find a lot of unexplained code and conventions. In this series, we'll take a slightly different approach. We'll start by creating a simple module, and we'll build on it. We'll concentrate on how to add your module to the system, what configuration files you need and why, and what a controller is in Magento and how you can work with it. We'll learn how Magento detects modules and processes requests, known as the request flow. We'll also go over routes and routers, also pronounced as routes and routers, and what makes your controller run. Let's get started. The main building block of Magento is a module. In Magento, module is a complex concept. Even the core engine, usually a black box, is a module, and it takes its place among the other modules. This is different from many other architectures, for example, Symfony. That's why to add functionality, we typically create a module, and you'll hear us referring often to modules. To add functionality to Magento, it's also useful to understand Magento's concept of code pools. We put all Magento modules in one place, the app/code folder, also pronounced app/code. Furthermore, if you take a look inside the code folder, you'll see three folders: Core, Community, and Local. If you install Magento using the downloader, you might not have a local directory. No problem. Go ahead and create it now. These represent code pools. What are code pools for? They are Magento's way to compartmentalize functionality and organize modules. The core pool is for basic functionality provided by the Magento team. The community pool is where you put modules created by third parties. You can get such modules from Magento Connect, the official online marketplace for Magento extensions. If you are developing a module for the Magento community, we recommend you do so in the Community folder. In all other cases, we recommend you use the Local pool. For example, you can put all the custom modules for your company in the Local folder. There are two additional benefits that Magento achieves by organizing the code into code pools. The first is the ability for you to easily install Magento upgrades. The second is the ability to elegantly override core functionality by way of a prioritization scheme. This prioritization scheme is the most interesting for us as Magento developers. How does Magento achieve this second benefit? The code pools are assigned a priority, with the local pool having the highest priority, and the core pool the lowest. Code in the lib folder has a lower priority than all three of the code pools. Let's take a look inside mage.php, where this logic resides. It's in the app folder. Take a close look at lines 38 through 48. These lines deal with code pool priorities. By the way, lines 27 through 29 define some shorthand. DS replaces the longer native PHP constant directory separator. PS replaces path separator. And BP, base path, represents in essence the path to the root folder. Magento creates an array, paths of full paths to the code pools, in a strict order, and assigns the array to the PHP include path. PHP looks for included files in the directories in the strict order they are listed in the PHP include path. Magento uses an autoloader, which is a mechanism to automatically map PHP class names to file names and include them. So, unlike the tedious routine you may be used to, in Magento you don't have to include classes manually. The PHP autoload function starts in the local folder. If PHP can't find the requested file in the local folder, PHP looks in the community folder, and finally, it looks in the core folder. If the file is not in the core, PHP looks in the lib folder. Thus, if there are 3 PHP files with identical names and paths in the 3 code pools, the file in the local code pool takes precedence. By the way, you can also use this prioritization scheme to override core functionality. Never edit files directly in the core code pool. Copy the core classes to the local folder and make your changes there. Furthermore, be careful with this technique because, though it's easy, you may lose compatibility with future upgrades. When you copy an entire core class to another code pool, you must remember to check the core class when Magento issues an upgrade, because the class you copied will be in a higher priority code pool and any upgrades from Magento of that class will be completely masked. So where are we going to put our module? For the purposes of this course, we'll put it in the local folder. On to namespaces. To add functionality to Magento, our first step is to create a namespace. At this point, it's very likely if you open the app/code/local folder, it will be empty. So let's take a look in the core folder. When you look inside the app/code/core folder, you don't see obvious modules. Instead, you see Mage and Zend folders. You may recognize Zend as a company name. These folders represent namespaces, also referred to as packages. The namespace is a unique identifier, usually a company, organization, or project. Using a namespace allows you to group all of your modules in one place and avoids interference with other system names or identifiers. Each contributing member of the Magento community should use their own namespace when creating modules. To create a namespace, create a folder in app/code/local. We'll call it Practice. We can place any number of modules in this folder. Excellent. On to the next step, creating module folders. Before we create our module folders, let's talk about a key point: naming conventions. As you may know, Magento ships with a checkout module, but in this module, checking out requires multiple steps. Let's say we want to facilitate one-step checkout in our online store. To do so, we have to create a new module. In your namespace folder, create a new folder called Controller Test. Notice the capitalization. We use this to make it easier for us to read the folder name. In your programming career, you may have used underscores to achieve the same end. In Magento, however, you should not use underscores when naming folders. Using underscores in this manner makes the items incompatible with Magento's custom autoloader mechanism, because the autoloader replaces all underscores with slashes. Magento uses the class variant_autoload located in the file autoload.php in lib/variant. This class overrides the native PHP autoload function with its own autoload method. Let's follow the script as the PHP interpreter does. Every user request of any Magento page runs the file index.php. If we open index.php, you will see the line require_once mage filename, which is a variable that stands for app/mage.php. That line moves us into mage.php. Then, the PHP interpreter runs 2 lines: include_once variant/autoload.php and variant_autoload register. And this static method register registers its own method autoload with the help of the SPL_autoload_register function, as you can see in line 73. The PHP interpreter passes each requested class through this method, and the method composes a corresponding path to the file of the requested class. Let's take a closer look into this auto-load method. Remember, in Magento, the class name typically incorporates the path. As you know, any given file has only one path, so you can only have one class per file in Magento. When the system requests, for example, new Magento model app, Magento's autoload mechanism uses the class name to build the path to the file, then runs return include class file, where class file in this case is converted to mage/core/model/app.php. I want to point out one detail on line 89 of lib/variant/autoload.php. Do you notice the use cwords function? For example, if you create a file inside a series of folders and name the file and folders using lowercase like this, practice/controllertest/model/myclass.php, and then write new practice_controllertest_model_myclass in lowercase as well, you'll get an exception because the UCWords function converts the string to practice_controllertest_model_myclass. All words are converted to initial caps. The autoloader will try to include the practice/controllertest/model/myclass.php file and of course won't find it. The UCWords function capitalizes the first letter of a word. So in order for the autoloader to find the files and folders using the path that gets created, we should always use initial caps when naming folders and files. The beauty of Magento's autoloader is that you don't have to manually add a bunch of include lines. The autoloader does this. If you're used to working with case-insensitive file names like Windows or Mac OS X, you likely haven't run into any errors caused by the case and file names. However, in the situation where you deploy Magento on a Unix-based system, this same insouciance will lead to very difficult to debug errors. So we recommend you get into the habit of using uppercase for the first character of directory names that contain PHP classes. To summarize, we don't create folders with underscores in the name. Secondly, we don't create files for classes with underscores in the name. Thirdly, we use initial caps when naming files and folders. And finally, when we write class names in files, we do use underscores to incorporate the path in the class name. The autoloader does all the including work. Okay, now we're ready to create the necessary folders inside our correctly named module. A module in Magento can comprise a number of folders. For now, we'll create a bare minimum for our module. That is an etc folder, also pronounced etc, and a controllers folder. The etc folder contains module configurations and system files. As expected, you will find only .xml files here. The controllers folder is for files that are controllers, as you probably guessed. This folder is not mandatory. If you don't have a controller in your module, you don't need this folder. The modules we're creating, however, does have a controller. We can't say the same thing about the etc folder because a module has no meaning if it doesn't have a configuration file. You must declare the module's existence in the configuration file for the Magento system to even find the module, let alone run it. That makes the etc folder mandatory. Let's create those two folders now. Once we've created these basic module folders, our next step is to create an initial configuration file. The configuration of Magento contains many settings and properties. There can be the definition of the code pool, activation flag, dependencies, name and version, class groups, own database connections, own setup model, layout and translation files, and any module-specific information. The logic of processing configuration files in Magento is complicated. In Magento, we have not one, but many configuration files. In a nutshell, Magento merges all configuration files in one configuration object, applying some sorting rules. We have apps/etc as the general folder for system-wide configuration files. By the way, this is different from the etc folder in our module folder, which contains module configuration files. Also, we have apps/etc/modules as the folder for initial configuration files specific to modules. Each module must have its own configuration file in the apps/etc/modules folder, or else the system will ignore the module. This file is something like a representative of the module. The name of the file may be anything you like, as long as it ends in .xml, but we recommend you name files based on the pattern namespace_module_name.xml. When Magento loads its configuration, it reads all the XML files in the apps/etc folder using the pattern *.xml. In most cases, this means reading only two files, config.xml and local.xml. Then, all file names from the apps/etc/modules folder are loaded into an array and sorted according to a sequence. This sequence is based on the names of the files. We want to get core configuration file names first and community and local configuration file names last. The resulting array will have file names with the prefix maj_all on the top, then all file names with the prefix maj, and finally the rest of the configuration file names. Next, Magento reads the content of the files in this array into a configuration object and sorts it according to the dependencies. This object won't contain much information. As we already know, the configuration files in the modules folder are just initial configuration files. Let's look at one of them, maj_downloadable.xml. They specify the activity state, code pool, and dependencies for the module. So once Magento finishes this step, we'll have a configuration object listing all of the modules in the order of their dependencies. After that, the system iterates each module in that object, and if the module's active flag is set to true, reads the module's etc/config.xml file. That is, the system merges all of the data from these files into this object. Now you know the order in which Magento loads configuration files. It's time to create the initial configuration file. practice_controllertest.xml in the apps/etc/modules folder, and add the content I show in this slide. Let's take a close look at these lines. The node config is like a global container of our entire configuration. As I said before, the system merges all configuration files from different places. That's why each configuration file starts its data from the config node. The same works for node modules. The modules node is a container for all modules we have in Magento. We must specify here our new module so the system can find and run it. And we've done that in this line. Do you remember the underscore naming conventions we discussed earlier? Accordingly, we specify the module using the pattern namespace_module name, the next two lines to find the activity state and code pool of the module. These lines mean that when the system loads the module's config.xml, it will check if active is true. And if so, it will build the path as follows: app/code/local/practice/controllertest/etc/config.xml. You can see how the system composes the path in the file app_code_core_maj_core_model_config.php on line 907. On to creating the main configuration file. We need to specify somewhere that our module has a controller, and the only place to do that is in the configuration. Therefore, let's create the main configuration file, namely config.xml. By the way, the name config.xml is hard-coded. Do not use another name. The full path is app/code/local/practice/controller-test/etsy/config.xml. The minimum information we must add are the lines between the config tags. Let's walk through each line. We can see here several familiar lines: config, modules, and practice_controller-test. When the system merges the initial practice_controller-test.xml and this config.xml, our configuration object will contain the following combined data in the practice_controller-test node. It looks like our configuration is separated into two pieces: the file practice_controller-test.xml and the file config.xml. You must put all configuration data relevant to the module in the second configuration file, config.xml, not in the initial practice_controller-test.xml file. The config.xml file can be as large as you need. When a module is deactivated, that is, the node active is set to false, none of its additional configuration files are loaded, reducing the size of the configuration object. This is one of the benefits of splitting the configuration, especially since the second piece of the configuration is often several XML files. Okay, back to the content of config.xml in the module's Etsy folder. Why do we add a version number here? Taking advantage of this convention is a handy way to upgrade your module. When you increment the version number, the system checks to see if there are any database upgrade scripts to run. We'll talk in detail about this later. Strictly speaking, we don't need a version number for this particular module, because we don't have any tables in a database yet. Still, it's good coding style to specify a version for your module. Let's move on to the next step, defining the controller. The next code we want to add is a definition for our controller, especially since the controller is the only working something in this course. Why a controller? Magento implements the MVC concept in its architecture. MVC stands for Model View Controller. We assume you know the details of the MVC concept. The system directs each request to the corresponding controller. In other words, the system searches for a controller which corresponds to the requested path in the URL. Then, the system calls the appropriate method of the controller and sends the output to the client. An interesting detail is that in the MVC acronym, C comes at the end, but in Magento's request processing, C comes first. The system stores all results of the controller's work in the object MageCore-controller-response HTTP. We call this the rendering process, and it concerns the V and M of MVC. In this course, we focus on the C of that acronym. These lines inform the system about our controller. Go ahead and add these lines to your config.xml file. You may wonder what front-end, routers, test controller, and other lines here mean. Briefly, front-end is an area. In the router node, also pronounced router, we create the configuration for the corresponding router, containing our route and controller. We use test controller as the unique identifier, wrapping all of our controller definition. What are area, router, and route? Speaking of areas, we have the back end to administer the system and the front end side for visitors. These two are areas. We call them front end and admin. It's a pure concept. If some options must be applied to all areas, we use the global area. The router is in essence a class, which is given a router role. This class is responsible for gathering all routes and corresponding controller classes which are addressed to him. The route is a concept we use to create the URL and mostly concerns the content of the front name node. When the system processes a request, the system searches for a corresponding controller, trying to find a match among all of the front name values in the loaded system configuration and a route name from the current request. That is why we call it a route, because the system uses it to arrive at a corresponding controller. We'll go into more detail later in the request flow video. Let's create the last piece, the controller file. Now we'll create the controller we defined in the previous lesson. Open the app/code/local/practice/controller-test/controllers folder. Create a new PHP file and call it indexcontroller.php. Open the file and type the code you see on the slide. What is a controller's role in the system? Controllers are responsible for processing the request parameters, initializing blocks, setting up the layout, preparing the response object, rendering the layout, and finally, processing exceptions. Some of these responsibilities are optional, but whichever ones you need, put them in the controller. A common mistake is to use business logic in the controller. Don't do it. The exception is if you're working with a module involving very simple business logic. Earlier, when we created the Etsy and Controllers folder for our module, you may have noticed the model and helper folders of other modules. The proper place for business logic is in these two folders for a given module. Now let's check if our controller works. Point your browser to the URL you see on the screen. Obviously, the first part of the URL depends on where you've located your copy of Magento. The easiest way to compose the URL is to point your browser to your home page and append /index.php/requestflowtest without anything else. You see, Hello World. Yay, it works! Now, let's learn how it works. Our test ran flawlessly, but what if it hadn't? What if, when you create a custom module, you don't get the results you expect? It's useful to know the sequence of steps the system takes to involve your module's controller so that when your module doesn't work as expected, you can pinpoint where to start troubleshooting. We call this sequence the request flow. In general, when you run your module, the system processes your request this way. The system finds your module's controller. The system finds the related method. The system executes the method and gathers the output. The system sends the output and you see the results. In this course, we'll explain all these steps except how the system gathers the output. How the system gathers the output is called rendering, and we'll cover it in the next course. Step 1. How does the system locate your module's controller? Let's take this URL as an example. To locate the system, the controller needs a route name and a controller name. The word catalog in the example URL is the name of the route. The word product is the name of the controller. Among the module's config.xml files, we have one in the catalog module with the definition of this route on line 619. Mage_catalog in the module node serves as the prefix. To compose a path to the controller, the system takes this prefix and then adds controllers lowercase. After that, the system takes the second part of the URL, product, capitalizes the first letter, and appends controller.php. The result is mage/catalog/controllers/productcontroller.php. The controllers folder is the only folder in this path with a lowercase name. Any idea why? Remember our previous discussion about naming folders with initial caps? We want any files in the controllers folder to be outside the sphere of the autoloader. By naming the folder with lowercase, we ensure that the autoloader won't find it. Instead, The system uses a corresponding router to include and instantiate an appropriate controller, bypassing the autoloader. Step 2. The system includes and instantiates the controller class and calls its method using the next part of the URL, the action name view. The system takes view and adds the word action. The result is view action. Then, the system checks if the product controller class has the method view action, and if so, runs the view action method as part of the dispatch method. What if a controller class does not have this method? The system searches the next corresponding controller. This means we can register several controllers for the same route in other modules. The system will iterate them all until it finds a controller with the method. As soon as the system finds a match, it stops searching. If a request does not contain a name of a controller, the system assumes index for the name. The same will work for an action name. The system will try to instantiate the index controller class and call the index action method of that class. The last two steps comprise gathering and sending output. In our module, the output was simply sent by an echo function. Now that we understand the entire sequence of steps in general, let's look at how the PHP interpreter takes these steps. As you remember, the system always starts from index.php. For step 1, open index.php in your root installation of Magento and scroll to line 80. That brings the interpreter to step 2. Open file app/mage.php and scroll to line 623. That code brings us to step 3. Open app.php in mage/core/model and scroll to line 340. Here, the interpreter sees two actions, getFrontController and dispatch. First, the interpreter calls the getFrontController method, which brings us to step 4. Scroll down to line 1055. This line brings the interpreter to step 5. Scroll up to line 712. And finally, you see step 6 in front.php in Mage Core Controller Variant on lines 126 through 153. The init function creates 4 instances of routers. Remember this. Typically, in Magento, we have 4 different routers. What are they? The constant XML store routers path equals web/routers, which means the variable routers info will contain an array based on data taken from the configurations node web/routers. I want to show you where this node is located and defined. Open the file config.xml in mage/core/etc and look at lines 284 through 288. At this point, the array routers info contains the data you see in this screenshot. We have 2 router codes, admin and standard. Each of these is also an array with an area name and a class name. Next, for each iterates this router's info array and creates an instance of each class. So, we have the class Mage Core Controller Variant Router Admin for the admin area, and the class Mage Core Controller Variant Router Standard for the front-end area. On line 140, you see that these 2 instances run their collect routes methods with their area name and router code as parameters. When the admin router calls its collect routes methods, it follows the same logic as the standard collect routes, because Mage Core Controller Variant Router Admin extends Mage Core Controller Variant Router Standard and doesn't override the method. We have only one actual place where this method, collect routes, is located, in the standard class. Then, 2 routers are stored in the current _FrontController object per line 142. The system adds the 3rd router on line 147. We won't go into a detailed explanation of the observer's mechanism, but you should know that when the system dispatches the event controller front init routers, it calls the init controller routers method of the Mage CMS controller router class. You can find this class in the router.php file. Open that file now and take a look at lines 42 through 48. The third router has CMS as a router code and an instance of itself as a class. The fourth and last router is the default router. It has default as the router code and an instance of the Mage Core Controller Variant Router Default class. You can see it in front.php on line 151. I want to emphasize that the order in which routers are listed in the array is important. This order is admin, standard, CMS, and finally default. To summarize what we've discussed so far, we have an instance of Mage Core Controller Variant Front class stored in the variable _front controller in the file Mage Core Model app.php on line 709. The system calls its init method on line 712. As a result, the front controller now contains 4 instantiated routers. The first 2 routers have corresponding routes. The CMS and default routers don't collect any routes. Before we go deeper into match logic, let's go back to the collectRoutes method. Remember, the system called the collectRoutes method during step 6 in the class Mage Core Controller Variant Front on line 140. You see here the realization of the collectRoutes method. Remember what we have in the config.xml file? The system takes those parts of the configuration which match the related router area names. We have only 2 options here, admin and front end. As you can see in lines 284 through 288 of config.xml in the Mage Core module. Remember this, you can use no other identifiers to add your controllers to the system, so the front end node in our module's config.xml file stands for the area or router identifier. By means of this identifier, we target the route of our module to, in this case, the front-end router. The next line, routers, is a container with a route and a controller class prefix in the module node. Actually, we don't have any routers in this node, but only routes. Routers are the target of this information. Don't be confused by routers here. The next line, test_controller, is our unique identifier of a controller. Be careful not to use the name of an identifier already in the system unless you want to override that route and controller. The use node must be defined to allow the current controller to be added to the system. Take a look at line 42. The system compares the word standard in the config.xml file with the router's codename. And again, we have only 2 options, but a bit different, admin and standard. If you want the system to add your route to the front-end router, you must use the word standard in the use node. In case you want to add your route to the admin router, you would use the word admin in the use node. Then, as you see on lines 43 and 66, the system takes the content of the module node and the front name and stores it on line 67 in the add module method. The code on lines 44 through 66 will not run for our configuration because we don't have any modules node for our route. However, in other circumstances, you can use the node modules in combination with a non-unique identifier to override existing routes in the system. Let's go back to step 3. Open app.php of the core module again and scroll to line 340. After the system initializes the routers and gathers the routes, it runs the dispatch method. The dispatch method aims to find, based on the URL, the best way to process the request, which consists of finding the most appropriate controller with an existing method and then executing the method. You can see that during the execution of this dispatch method, the system calls 2 rewrite methods. The first one, on line 166, applies all of the custom URL rewrites with the help of the Mage Core Model URL Rewrite class. The second one, on line 170, applies the configuration rewrites from the configuration files to the current URL. Then the system loops, trying to match the current URL request to one of the routers, as you can see on lines 174 through 180. The system continues looping as long as the isDispatch method returns false, or the variable is less than 100. Simultaneously, the system cycles through the _routers array in a nested loop. Do not ask me why 100. This is a magic number. Obviously, we want some limit to avoid an infinite loop, but 100 cycles is more than enough to process the received request. But again, why 100 cycles if we have just 4 routers? Some routers later in the match method loop can modify data, and the system must repeat the match loop to incorporate those changes. We set the _dispatch flag to let routers listed earlier in the loop match the request again. Only the admin and standard routers will set this flag to true immediately if matched. The CMS router has its own match method where it makes some modifications. It typically doesn't change the dispatch flag, but continues the cycle, expecting the system to find the match through one of the other routers. This is a critical process to understand. This is how the system delegates the module's work to the responsible controller. During bug fixing, you can use your understanding of the delegation process to trace which router processed the request and thus pinpoint where to start troubleshooting. Now let's learn about the last step. The match method does all of the search work. It tries to find the correct controller class and call its requested method. We have only 3 realizations of the match method. One is contained in the Mage Core Controller Variant Router Standard class. The second is in the Mage CMS Controller Router class. And the last is in the Mage Core Controller Variant Router Default class. The admin router extends, doesn't override, the standard class match method. The CMS module manages its own set of pages and has its own match logic. The CMS router checks whether the request is for one of the CMS pages, and if so, pulls the appropriate data in the request object. CMS router expects the system to find the match in the standard router on the next cycle. If the CMS router doesn't find a match, the default router steps in and implicitly puts predefined data into the request object to direct the system to show a 404 page on the next cycle. How does a default router direct the system? Actually, the default router takes values from the system configuration from the path on line 32. This data is defined in config.xml of the CMS module on line 200. The value is cms/index/no-route. Then, the default router sends this data into the request object and expects that other routers will find a match for the path. Again, this is possible because of that magic 100-cycle loop. The standard router matches the new request. CMS/index/no-route directs the system to index controller of the CMS module and calls the no-route action method. As you can see, the standard router plays a very important role in the matching logic. The CMS router is a good example of how you can add a custom router to the system using the Magento event dispatching mechanism. Neither the CMS nor the default routers set the dispatch flag to true, but expect the standard router to complete the match. So let's concentrate on the match method of the standard router. Open the file standard.php in the Mage Core Controller Variant Router folder. The match method consists of more than 150 lines of code. We'll restrict ourselves to only the most important details for us. The module variable contains the first part of the URL, the router name. This is catalog in the case above, remember? It is set on line 129 in our case. Then, on line 146, the system takes an array of the corresponding module prefixes by requested route name via the getModuleByFrontName method. These module prefixes were grouped into an array earlier on a collect route step. So, in the underscore modules array, the key of the element is a route. The value of the element is a module prefix. You can find the route on line 15 and the module prefix on line 14. We have plural modules here because there can be more than one module registered on the route. So the system iterates them all and looks for a valid class and a valid method. You see this process in lines 170 through 214. Let's look step by step. The system takes the controller name on line 178 and the action name on line 193. Then it validates whether the class exists on line 200 and creates its instance on line 206. If hasAction detects no valid method, the loop continues until it finds a valid match, meaning a valid controller and method. Then, the system sets the valid variables in the corresponding properties on lines 241 through 244 and calls the controller's dispatch method on line 253. The system also sets the underscore dispatch flag to true on line 252 to end the loop of that magic 100. Now the rest of the work depends on our controller. Practice underscore controller test. The system uses the dispatch method from Mage Core Controller Front Action anytime a controller doesn't have its own dispatch method, which is the case in our controller, and in fact is usually the case. That brings us to the abstract class, Mage Core Controller Variant Action. The most interesting thing for us is on line 420. Here the system calls our index action method, and the method echoes the Hello World string. All of this discussion describes how the system hands over the work of processing the request to the module's controller. Our module, Controller Test, is very simple, and you quickly saw the results in the test video. Most modules, however, are much more complicated than this, involving rendering a layout, accessing tables, etc. Nonetheless, we've covered a lot in this lesson. To summarize, we took a close look at these files, which are involved in request flow processing. In front.php, we learned about the init and dispatch methods of the Mage Core Controller Variant Front class. In config.xml of the core module, we learned about the two of the system router definitions, admin and standard. Then, in standard.php, we delved into collect routes and match methods. In admin.php, we learned that this class uses collect routes and match methods of its parent, standard.php. In router.php of the CMS module, we learned the reason behind looping the 100 cycles and its dispatch flag. Also, you might notice how you can implement your custom router based on the CMS router example. In default.php, we learned how the default router directs the system to a 404 page using the standard router. It sends other values into request objects, and then the standard router steps in again and finds a match in a controller of the CMS module. And finally, in action.php, we briefly touched on the dispatch method, which is implemented here for all controllers. In this exciting journey, we walk through all the logic of processing a user request, from the initial request to the point where the system calls an appropriate method of an action controller. Now turn to the next video, where we summarize the entire course. Congratulations! You have created a basic module in your Magento installation. Let's review what we did. First, we created a namespace. Our second step was to create module folders. Next, we created an initial configuration file. In the fourth step, we created the main configuration file for our module. Fifth, we defined a controller for our module. Then we created the controller we just defined. And finally, we tested our new module by viewing a URL. You now know the fundamentals essential to creating any module in your future. Thank you for watching. Be sure and visit the Magento support site for more learning resources.